So in this chapter in 7.2, we have applications to the normal distribution. Our first problem we're going to look at is problem number 27 on page 307. In a recent study, the Centers for Disease Control and Prevention reported that the systolic blood pressure of adult women in the United States are approximately distributed with a mean of 80.5 and a standard deviation of 9.9. The first question is, what is the proportion of women that have a blood pressure lower than 70? Here we can do the problem in two ways. One is we first find the z-score and then we look it up on the table to find the probability. Or we can use our calculator under second vars. The first problem, the way we would first calculate it, is if we're doing it by hand, we would do it the following way. We want to find the probability that z, now we're transferring it to a z variable, is less than 70 minus 80.5 divided by 9.9. So the reason we're doing this is we're transferring from the x variable to the z variable. When we do this, we get the following results. The probability that z is less than, after we do the calculation, is a negative 1.06. And when we look this up on the table of A2 under the standard normal, this is approximately equal to 0.1446. So the idea was we transfer this to a z interval and we can do the calculations right away. And notice we can do the calculations right away because it's less than, and our table works that way. So if we had a table, for example, and let's show you what we're talking about, is here is our standard normal distribution. And our mean value is here at 80.5. And our x value is at 70. So we're looking at the value on this side. Well, we can't do it directly, so we have to use the standard normal curve, which is the z table, in order to find the probabilities that has been shaded. Now, the other option is we can use our calculator. And in our calculator, under second vars, so it's normal, CDF, and we go to the lower bound, which in this case is going to be a negative E99, or so it's going to be 1 E99 minus, right? And then it's going to be the upper bound is 70, and the mean is 80.5, and then 9.9 is the standard deviation. And when we hit enter, we get approximately 0.1444. So now the second question is, what is the proportion of women that have blood pressures between 75 and 90? Well, in this case, we have to break this down into two pieces. One is the upper piece and the lower piece if we're doing it by hand. So the way we do it by hand is the following. We will let this equal to be the probability that x is less than 90 minus the probability that x is less than 75. And the reason we do that is we have to break it up into two pieces because it's an interval. So Now we can transfer to a z variable. So when we do that, we have the probability that z is less than 90 minus 80.5 divided by 9.9 minus the probability that z is less than 70, or 75 in this case, right? 75 minus 80.5 divided by 9.9. And when we do the calculations, we end up with the probability that z is less than 0.96 minus the probability that z is less than negative 0.56. So we have to look those up on the z table. And when we do that, we end up actually looking at 0.8315 minus 0.2877, and that gives us a final probability of about 0.5438. And that's an approximation. So our probability, so the proportion is about 54%, 54.4% of the women's blood pressure for diastolic blood pressure is between 75 and 90 is approximately 54.4%. Again, if we did this using the calculator, we would go to the second vars and we would use normal CDF, and this time the lower bound is 75 and the upper bound is 90. Again, the mean is 80.5 and the standard deviation is 9.9. Here we get an approximation of 0.5421. So we're off a little bit. Again, there's rounding issues, and of course the table's not exact. So in our last question that we're going to have this time is we're looking at the diastolic blood pressure that is going to be greater than 90. And the reason why is in this problem it says a diastolic blood pressure greater than 90, it should say greater than 90, is classified as hypertension. What proportion of women have hypertension? So we can put the probability statement as the following. The probability that X is greater than 90. Well, in this case, we can't solve it directly because we don't have a z variable. And the other issue is now we're looking at the following idea. So if we have the normal distribution, and you should probably always kind of draw these to get a clue as to how this works. Here is our 80.5, and now we're looking at something at 90, and we're looking at this area here. But our table only gives us probabilities on this side. So guess what we have to do? So this is going to be 1 minus the probability of X less than 90. And now we only have to deal with this probability. So it's 1 minus the probability, we're changing it to a z-score, is less than 90 minus 80.5 divided by 9.9. And now this is equal to 1 minus the probability. When we get to that point, I think we've already done it, 0.8315, and this gives us an approximation of 0.1685. Now again, we can use our calculator, and when we do that, normal CDF, we start out at the lower bound being at 90. The upper bound is 1E99, and then we have the mean is 80.5, and the standard deviation is 9.9, and then we get about the same answer. It might be off a little bit, but I think we get about 0.1686. Okay. Our second problem that we're going to look at is on page 309, problem 48, exam scores. Scores on a statistics final in a large class were normally distributed with a mean of 75 and a standard deviation of 8. Notice that we have to have this phrase in order to use either the standard normal curve from tables transferring from an x to a z, or we have to use the calculator, the norm CDF function. So now the question is, what is the proportion of scores that were above 90? So we want the following probability statement. The probability that x, which is the scores, is greater than 90. And again, what we're going to do is by hand, it would be 1 minus the probability that x is less than 90, similar to what we did last time, and we have to change it to a z variable. So when we do that, we get 90 minus 75 divided by 8, and when we do the calculation we get 1 minus, and then we look it up on the actual table. We round up to 1.88 and we get 0.9699 from the z table. Okay, and so our probability, the proportion that are above 90, looks to be about 3%, or 0.0301 approximately. And so we can also do this using the calculator, and how we would do that is the normal CDF. We'd start out at 90, we would go to 1E99. We have a mean of 75, and of course it's 8. And the question is, we probably should get about the same answer. When I do it on my calculator, which I'm doing right now, 90, comma, E99, comma, 75, comma, and 8, I get 3.04. So I get 0.0304 about. That's an approximation. So again, I'm off a little bit. And the second one, we want to know the scores below 65. So again, our statement is the probability that x is less than 65. And now we don't have to do any transformations other than to the z transformation. So it's z less than 65 minus 75 over 8, which is equal to the probability that z is less than, when we do our calculation, we get a negative 1.25, and when we look that up, this is 0.1056. And again, we can use the calculator to do this calculation, right? Normal CDF. The lower bound is a negative E99, comma, 65, 75, and 8, right? And again, I think technically we get about the same answer. A negative E99, comma, 65, comma, 75, comma, 8, and we get the same answer actually. We get the exact same answer, which is good. Now, the next question is kind of interesting because what we're actually asking for is we're asking for a value of x such that the probability under x is 40%. So essentially what we're starting out at, here's 75, and so now we're looking at a value of x where the area is 0.40. So it says what's the 40th percentile of grades. So we're actually looking for this area. Well, the question is how do we approach this particular problem? It turns out that if we start out with this idea of z is equal to x minus mu over sigma, with some algebra, we can show that mu plus z times sigma is equal to x. So this is the x that we're trying to actually find. So what we need to find is a particular z value and put it into this equation. So to do that is we go into the table, into the table itself of A2, and we get close to inside the table 0.40 and then find a z value. So our first method is to find a z value. The closest we can find for the z value for this comes out to be under A2, it turns out to be 0.4013. So, and then the z value that's related to that, z is equal to a negative 0.25. So we're going to use that information to find x. So mu we know, it's 75, plus z, now it's a negative 0.25, and we multiply it by 8, and when we do that, we get 75 minus 2 is equal to 73. So our value is going to be 73 in this particular case. In class, we'll talk about how to get from area to a value of x using the inverse norm function. The inverse norm. Okay, that concludes our problems in 7-2.